Ever wonder why you can breathe on Earth but not on Mars or Venus? This is where the importance of planetary atmospheres comes into play. These invisible blankets of gases surrounding planets are not just for show. They play a vital role in supporting life as we know it, shaping worlds and painting the cosmos with their unique characteristics. So, buckle up as we set course on a fascinating journey, exploring the birth, evolution, and future of these cosmic shields. Hang tight, space enthusiasts, as we delve into the evolution of planetary atmospheres. To understand the evolution first, we need to grasp what an atmosphere is. So let's dive right in. But before we take that deep plunge into the mysteries of our universe, remember to like this video and subscribe to our channel. Now, are you ready? Let's go. An atmosphere is a protective layer of gases surrounding our planet. It's like a giant security blanket, shielding us from harmful radiation, maintaining our climate, and providing us with the air we breathe. It's made up of several different gases, primarily nitrogen and oxygen, but also contains trace amounts of argon, carbon dioxide, and other gases. Now, let's consider the vital role an atmosphere plays in nurturing life. The atmosphere acts as a thermostat, regulating the temperature of our planet. It absorbs heat from the sun during the day and radiates it back into space at night. This ensures our planet doesn't get too hot or too cold, making life as we know it possible. Moreover, our atmosphere protects us from meteoroids. These space rocks burn up when they hit the dense atmosphere, appearing as shooting stars in our night sky. Without our atmosphere, these meteoroids could cause catastrophic damage. But not all atmospheres are created equal. Take Mars, for instance. Its thin atmosphere, made up mostly of carbon dioxide, is incapable of retaining enough heat to support human life. Or look at Venus, with its dense atmosphere causing a runaway greenhouse effect, making it the hottest planet in our solar system. Jupiter and Saturn, the gas giants, have massive atmospheres composed mainly of hydrogen and helium, resembling the Sun more than a terrestrial planet. The outer planets, Uranus and Neptune, have atmospheres rich in ices, such as water, ammonia, and methane. These variations in atmospheres across our solar system show us just how unique and precious our own Earth's atmosphere is. The balance of gases, the protective shield it provides, and the climate control it offers all work in harmony to create the only place we know of in the universe that supports life. Now that we've got the basics covered, let's jump into our cosmic time machine. Onwards to understanding how these atmospheres were born and how they've evolved over billions of years. Buckle up, it's going to be a thrilling ride. The birth of an atmosphere is a fascinating cosmic event. It's a tale of fire and ice, of volcanoes and comets, and of the raw, unyielding forces of the universe shaping the worlds as we know them. Let's travel back in time, to the early stages of a planet's life. Picture a young, fiery planet, freshly formed from the dust and gas of a newborn star. This process, called accretion, is the first step in the birth of an atmosphere. As the planet grows, it gathers more and more material, and with it, the basic ingredients for an atmosphere: hydrogen, helium, and other trace elements. But the story doesn't end there. Once a planet has formed, it enters a stage known as outgassing. This is where things really start to heat up. The intense heat and pressure inside the planet cause gases stored within its rocks to be released, contributing to the growing atmosphere. In this stage, volcanic activity plays a starring role. As volcanoes erupt, they spew out gases like carbon dioxide, nitrogen, and water vapor, further enriching the planet's atmosphere. And then, there are the comets. These icy wanderers of the cosmos carry water and other volatile materials. When a comet collides with a planet, it delivers these ingredients directly into the atmosphere. It's believed that comets played a crucial role in delivering water to Earth, contributing to the unique, life-sustaining atmosphere we enjoy today. So, the birth of an atmosphere is a complex and dynamic process. It's not a one-time event, but a continuous process of accretion, outgassing, and bombardment by comets. It's a cosmic dance choreographed by the laws of physics, and it's happening right now on countless planets across the universe. But these newborn atmospheres don't stay the same forever. They evolve. And that, my friends, is a story for another scene. Just like living beings, atmospheres also evolve. This isn't just a poetic sentiment, it is a fundamental truth of our cosmic existence. Let's take a closer look at how these celestial shrouds change over time. Atmospheres are not static. They interact with both the surface and space, undergoing constant change. One key factor in the evolution of atmospheres is solar radiation. The sun, our very own stellar dynamo, bombards planets with high-energy particles. Over billions of years, this constant solar wind can strip away a planet's atmosphere, especially if the planet lacks a protective magnetic field. Now, let's consider Earth, our home, as an example. The Earth's atmosphere didn't always look as it does today. In the early days, about 4 billion years ago, it was mainly composed of nitrogen, carbon dioxide, and water vapor, with very little oxygen. The oxygen we breathe today was a byproduct of photosynthesis from early life forms like cyanobacteria. These microscopic organisms transformed our atmosphere, making it hospitable for oxygen-breathing life forms, such as us. Geological activity also plays a significant role in shaping atmospheres. Volcanic eruptions, for instance, spew gases into the atmosphere. Over time, these gases can accumulate and change the composition of the atmosphere. On Earth, volcanic activity contributed to the high levels of carbon dioxide in the early atmosphere. Life forms and geological activity don't just affect the composition of the atmosphere, they also influence its temperature. The greenhouse effect, where certain gases trap heat from the sun, is a prime example. Without it, Earth's average temperature would be a chilly -18 degrees Celsius, instead of the comfortable +15 we enjoy today. So, we've seen atmospheres are not static entities. They change, they evolve, influenced by a variety of factors, from the sun's radiation to the smallest microorganisms. It's a complex interplay of cosmic and terrestrial forces that creates the atmospheric conditions we experience today. So, we've seen how atmospheres can change, but what does the future hold? Let's continue our journey and find out. Peering into the future of atmospheres is like gazing into a cosmic crystal ball. When we look ahead, we see a myriad of potential scenarios, each as fascinating and complex as the next. So, what could the future hold for Earth's atmosphere? Well, one possibility is a more carbon-heavy atmosphere thanks to human activity. As we continue to burn fossil fuels and release carbon dioxide into the atmosphere, we're essentially changing its composition. This could lead to a warmer planet and more extreme weather, a future that we're already beginning to see. But human activity isn't just shaping Earth's atmosphere, it could play a role in creating atmospheres on other planets too. As we venture further into space, we might one day terraform planets like Mars, creating a new breathable atmosphere. Imagine that, a human-made atmosphere on a distant planet. It's a concept straight out of science fiction, but one that could become a reality in the not-too-distant future. And what about the atmospheres of exoplanets? Those distant worlds orbiting stars far beyond our own solar system. With advancements in technology, we might one day be able to detect and study these atmospheres, giving us even more insight into the possibilities of life beyond Earth. From their birth to their future, atmospheres have quite the cosmic story to tell. Our journey through the evolution of planetary atmospheres has been nothing short of stellar. We've traversed the cosmos, delved into the mysteries of the universe, and discovered the intricate dance of elements that make up the air we breathe. We began our adventure by unraveling the basics of atmospheres, which are, in essence, layers of gases that surround a planet or other celestial bodies. These gaseous envelopes serve as a protective shield, guarding against harsh cosmic radiation and providing the conditions necessary for life as we know it. Then, we journeyed back in time to the birth of atmospheres, a process as fascinating as it is complex. We learned that atmospheres didn't simply appear out of thin air, but were the result of countless cosmic events. From the remnants of the Big Bang to the volcanic eruptions on young planets, each played a crucial role in creating the atmospheres we see today. Next, we delved into the evolution of atmospheres. It's a tale of transformation, driven by geological processes, biological evolution, and cosmic collisions. We learned how the Earth's atmosphere evolved from a toxic blend of gases to the life-sustaining mix we breathe today. a testament to the resilience and adaptability of life itself. Looking forward, we pondered on the future of atmospheres. As we continued to explore the cosmos, we might uncover planets with atmospheres that could potentially harbor life. Or perhaps we'll witness the birth of new atmospheres, giving us insights into the cosmic cycle of creation and destruction. This journey has only scratched the surface of our understanding of planetary atmospheres. The cosmos is vast and full of mysteries waiting to be unraveled. So, let's keep exploring, keep asking questions, keep pushing the boundaries of our knowledge. Remember, the next time you take a breath, you're partaking in a cosmic dance billions of years in the making. Until next time, keep looking up, space enthusiasts.